Wind can be a powerful force. Even though it can be impressive, wind is really just air in motion. We can harness this kinetic energy and use it for things like cooking our food or running our washing machines. All it takes is a little science. The beauty of wind turbines is that they're 100% clean. They don't belch out pollution or greenhouse gases like big power plants. But there's one big problem. No wind, no energy.
The wind speed tends to get higher as you go farther from the ground. And so a taller turbine will catch more wind because there's more wind up there.
As long as it has to be taller, we might as well make the whole thing bigger. Bigger blades catch more wind energy, and that equals more electricity. But there are limits.
Turbines onshore have gotten so big that it's hard to transport them. And so we'll put them offshore where we have big barges and bigger cranes, and it's actually a little easier.
So at what point does this become this? As wind passes by the turbine, the blades rotate. This rotating action turns a magnet inside, which is surrounded by wire coils. Each time the positive and negative poles of the magnet pass by those coils, they move electrons along the wires. Electrons moving in this way create an electrical current. I visited the National Center for Atmospheric Research in Colorado to see how researchers are studying wind.
Okay, so wind is free, wind is great. How does what you do play into the whole wind energy story?
Well, a very important part of wind energy prediction is trying to tell the folks who run the electrical system when the wind's going to blow so they could take advantage of it. You have to blend wind in with all of the other power generation sources like coal and natural gas.
So what about a regular weather prediction? Is that enough to tell you whether or not the wind is going to blow?
Well, weather predictions you typically see on TV will talk about what the average wind is likely to be for the day. But the power companies need information very specific to where their wind farms are and the time of day.
Scientists often make predictions based on models, whether they're physical or mathematical. Models help with predictions because they can make complex problems simpler.
The system we're developing is really special because it takes information in from the global scales all the way down to the local scales, and in real time it processes all that data to generate a forecast specific to every single wind turbine.
So we know where to find the wind. We know how to change the wind's energy into electrical energy. And we know how to predict when the wind will blow at its strongest. But it isn't always windy enough. Ever heard of the jet stream? It's a river of wind miles above us that moves anywhere from 60 to 250 miles per hour almost all the time. Researchers are already thinking about ways to harness its energy using kite-like devices. Wind energy is becoming more common, whether it's a few small turbines on a building or a huge wind farm that helps power a city. In fact, wind is the fastest growing source of renewable energy. In the future, wind might provide all the electricity we could ever need. Or maybe someone will come up with an even better idea. With science, the possibilities are endless. So next time you get yelled at for having your head in the clouds, don't worry. Science happens there too.